Ukraine, Eastern Front, March 15, 1944, 11:47 hours. Oberfeldwebel Hans Becker stood beside his Panther tank, 56 tons, 75mm gun, armor that could stop any Allied shell. Cost to build, 117,000 Reichsmarks, about $2 million today. The Panther had been sitting immobile for 11 days. Not destroyed, not damaged, just stopped. The problem? A clogged fuel filter. A cylinder of metal and paper, roughly the size of a coffee can. Cost, 8 Reichsmarks, about $3. His unit received 2 replacement filters per month. His Panther needed a new filter every 150 kilometers. They'd driven 450 kilometers since the last supply convoy. 3 filters needed, 0 available. "How long?" asked Lieutenant Weber. "Until we get a replacement, Herr Leutnant. Supply says 2 weeks, maybe 3. 300 meters away, Sergeant Mike Kowalski climbed out of his Sherman after an 80-kilometer advance. "Fuel filter check," his crew chief called. They pulled the filter, standard maintenance every 500 kilometers, dirty but functional. They change it anyway. "Got a spare?" "Got 12. Fresh convoy this morning." 4 minutes later, the Sherman was running, ready for another 500 kilometers. Across the field, Becker's Panther sat silent. 2 weeks later, Soviet forces would overrun the position. Becker's crew would destroy the Panther with explosives rather than let it be captured. A $2 million tank, lost to the war, defeated by a $3 filter that never arrived. This is the story of how Germany lost the Eastern Front, not to Soviet guns, but to fuel filters, oil seals, spark plugs, the unglamorous parts that keep machines running. This is the story of how a $3 part changed history. Germany, 1941, Operation Barbarossa. German tanks smashed into Soviet lines, expecting quick victory. Instead, they encountered the T-34, sloped armor, wide tracks, powerful gun. German tanks were suddenly obsolete. Hitler's response? Build something better, immediately. The result? The Panther. On paper, it was magnificent. 80mm sloped armor, impenetrable from the front. 75mm gun, could kill any Allied tank at 2,000 meters. 700 horsepower Maybach engine. Zeiss optics accurate to 2.5 kilometers. The Panther could destroy a Sherman before the Sherman even saw it. German engineers called it the perfect tank. They were wrong. The fatal flaw was hidden in its sophistication. The Maybach HL-230 engine was a precision masterpiece. V12, dual overhead cams, 4 carburetors, tolerances measured in hundredths of millimeters. This precision required pristine fuel. Even tiny particles, dust, rust, water, would damage injectors in carburetors. German solution: filter everything aggressively. The fuel filter, Kraftstoff filter type 42/G, filtered particles down to 10 microns, required replacement every 150 kilometers. In field conditions with poor fuel, every 80 to 120 kilometers. Compare this to the American Sherman. The Sherman's Continental engine was designed for abuse. Loose tolerances, single carburetor, could run on anything from 68 to 80 octane fuel. Its fuel filter was coarser, 40 microns instead of 10, allowed more contamination through, but the engine could handle it. Result? Sherman filters lasted 800 to 1,000 kilometers, 5 to 10 times longer. Germany could make fuel filters. The problem was getting them from factories to tanks across 2,000 kilometers of hostile territory. What happened in between would doom the Panther before it ever faced an enemy. The journey. Factory to front equals 2,100 kilometers. German supply chain, factory, castle, regional depot, Frankfurt, 2 to 7 days. Frankfurt, Poland by rail, 7 to 14 days, if tracks intact. Poland, Ukraine by truck, 7 to 14 days, through partisan territory under Soviet air attack. Forward depot, tank, 3 to 7 days, paperwork, approval. Total time, 24 to 48 days. Loss rate, 35 to 40% destroyed in transit. American supply chain, factory, 12 sites, depot, New York, 1 to 3 days. Atlantic crossing, 12 to 14 days. UK, France, 2 to 4 days. Forward depot, tank, same day. Total time, 18 to 24 days. Loss rate, 8 to 12%. The critical difference: America sent redundant shipments. If one convoy sank, 2 others carried the same parts. German shipments had no backup. Feldwebel Otto Schmidt, Panther crew, kept a journal. March 8, 1944. Filter clogged after 90 kilometers. Used last spare. Requested replacement. March 15th. Still waiting. Tank cannot move. 6 tanks immobile, all waiting for filters. March 22nd. 2 weeks now. Supply says convoy attacked by partisans. New convoy 5 to 7 days. March 29th. Received 1 filter. Also received order to abandon tank and join infantry. Soviet offensive expected. Will destroy Panther. April 1st. Demolished tank with explosives. Engine perfect. Gun perfect. Armor undamaged. Abandoned because of fuel filter. Schmidt's Panther, built January 1944 at 117,000 Reichsmarks. Service life, 73 days. Distance traveled, 412 kilometers. Combat victories, 3. Cause of loss, lack of $3 fuel filter. German records, Army Group Center, March-April 1944. Total Panthers, 287. Combat ready, 127, 44%. Destroyed by enemy, 23. Awaiting major repairs, 51. Immobile due to minor parts, 86, 30%. Of those 86, fuel filters, 31 tanks. Oil filters, 18 tanks. Air filters, 12 tanks. Other small parts, 25 tanks. 86 tanks, $170 million, sitting immobile because of parts worth less than $100 per tank. American 3rd Armored Division, same period. Total Shermans, 390. Combat ready, 341, 87%. Immobile due to parts shortage, 7, 2%. The Sherman wasn't more reliable. It broke down just as often. But it was repaired in days, not weeks, because parts arrived constantly. By mid-1943, German logistics were strained, but functioning. Then Allied bombers discovered where Germany's filters were made. What happened next would turn a problem into a catastrophe. Schweinfurt, Germany, October 14, 1943. 291 American B-17 bombers appeared over Schweinfurt, home to Germany's ball-bearing production. Also home to factories producing filters, gaskets, and seals. The Americans called it Black Thursday. They lost 60 bombers, 20% casualties, but the bombing achieved its goal. 3 ball-bearing plants destroyed. Collateral damage: 2 fuel filter factories, 1 air filter plant, 3 seal manufacturers. Albert Speer, Minister of Armaments, responded quickly. Ball-bearing production dropped 67%. Speer dispersed production, increased shifts, tapped stockpiles, imported from Sweden. Result: ball-bearing production recovered to 85% by March 1944. But Speer didn't mention fuel filters in his report. Filters seemed trivial compared to ball bearings. Nobody at ministerial level realized filters, not ball bearings, would become the bottleneck. What actually happened? Ball bearings recovered to 85%. Speer succeeded. Fuel filters recovered to 45%. Stayed at 45 to 50% for the rest of the war. Why didn't filter production recover? Nobody prioritized it. Not tracked like ball bearings. Specialized equipment couldn't be moved. Filter paper supply chain disrupted. Skilled workers drafted or diverted. Allied raids continued on all industrial cities. German attempted solutions. Extend filter intervals. Use filters up to 200 kilometers. Reality, filters clogged at 120 kilometers. Extending intervals damaged engines. Clean and reuse. Clean soiled filters with solvent. Reality, paper degraded after one use. Cleaned filters 30 to 40% effective. Capture enemy filters. Soviet and American filters incompatible with German engines. Improvised filters. Some crews tried cloth, mesh, even cigarette paper. These lasted 10 to 20 kilometers before catastrophic failure. Obergefreiter Paul Zimmermann tried an improvised filter in Normandy, June 1944. We had been immobile 9 days. Soviet offensive started. Our mechanic made a filter from parachute silk and engine oil. Tank ran 6 kilometers. Then engine died. Fuel system contaminated. Injectors destroyed. We abandoned tank. Tank cost 117,000 Reichsmarks. We destroyed it trying to save 8 Reichsmarks on a filter. Zimmermann's Panther, 87 kilometers traveled, 12 days service life. Destroyed by improvised filter. By summer 1944, German tank units faced impossible choices. Risk engine damage with improvised solutions or sit immobile. But American intelligence had discovered this weakness, and they were about to exploit it systematically. London, March 1944. Allied intelligence. Captain Robert Morrison compiled a report analyzing German tank performance. German tanks demonstrate superior combat performance. However, operational readiness averages only 40 to 45%. Investigation reveals non-combat mechanical failures account for 55 to 60% of armor losses. Of these, 35% are fuel system and filter related. Enemy capable of producing excellent vehicles, but incapable of maintaining them in field conditions. Recommendation: target German logistics and small parts manufacturing. The report reached Eisenhower in April 1944. His response: can we make this worse for them? Operation Point Blank adjusted targets. New priority list. Oil production. Aircraft factories. Ball bearings. Transportation infrastructure. Rail yards. Bridges. Small parts manufacturing. German supply system relied on trains. If supplies couldn't move by rail, they often couldn't move at all. Results: May-August 1944. German rail capacity, May, 89% of January levels. June, 71%. July, 58%. August, 42%. Each month, moving supplies from Germany to the front became harder. General Major Walter Nering, 24th Panzer Corps, July 1944. We have Panthers in depot. We have fuel. We have ammunition. What we don't have: filters, plugs, seals, all stuck on trains between here and Germany. Yesterday, a convoy arrived with 200 artillery shells. Useful, but it should have carried maintenance parts. Those never loaded, priority given to ammunition. I have tanks that cannot move to fire their guns. American contrast. Red Ball Express. Dedicated truck convoys, 24/7 operation, moving supplies from Normandy to front lines. Priority cargo. Ammunition, fuel, maintenance parts, food. American doctrine. A tank that can't move can't fight. Moving requires maintenance. Therefore, maintenance parts are as important as ammunition. Sergeant Frank Patterson, 3rd Armored Division Supply. I treated fuel filters like ammunition, requested 200% of needs, actually received 150 to 180%, maintained 30-day stockpile, never waited more than 3 days for critical parts. We changed Sherman filters every 400 kilometers, even though they could go 800. Better early than risk breakdown. We threw away filters with life left, seemed wasteful, but we never had a tank immobile waiting for a $3 part. Later, I heard Germans were cleaning and reusing filters. That's when I knew we'd won. The mathematics. German Panther availability, operational, 45%, under repair, 25%, awaiting parts, 30%. American Sherman availability, operational, 87%, under repair, 11%, awaiting parts, 2%. Quantity of available tanks mattered more than quality of individual tanks. By autumn 1944, German armored forces were bleeding tanks to logistics failures. Then Hitler ordered one last desperate offensive. What happened in the Ardennes would prove that superior tanks were worthless without the parts to keep them running. Ardennes, Belgium, December 16, 1944, 0530 hours. Germany's final offensive. 250,000 soldiers, 1,400 tanks. The plan? Reach Antwerp in 7 days, split Allied forces. Speed was essential. But Germany had a problem. Oberst Friedrich von der Heydt, 6th Panzer Army Logistics. Before the offensive, von der Heydt reviewed supply allocations. His requisition: 500 fuel filters, 500 oil filters, 1,000 spark plugs. Approved. 180 fuel filters, 140 oil filters, 200 spark plugs. His calculation: parts sufficient for 2 to 3 days under combat conditions. He requested more. Response: no additional parts available. Capture enemy supplies. Von der Heydt's diary, December 12th. We are launching the most important offensive of the war with maintenance supplies for 48 hours. After that, we depend on captured American depots. If we don't capture supplies within 2 days, half our tanks will be immobile, independent of combat losses. I conveyed this to higher command. I was told, advance fast enough and maintenance won't matter. This is insanity. December 16th to 18th. Initial success. German tanks advanced rapidly, but the maintenance log told a different story. 1st SS Panzer Division. Day 1, 97 tanks operational. Day 2, 89 tanks. Day 3, 76 tanks. Combat losses, 8 tanks. Maintenance failures, 16 tanks. More tanks lost to maintenance than to American guns. Why? December 1944 was brutally cold, 10 degrees Celsius to minus 15 degrees Celsius. Cold weather meant fuel thickened, filters clogged faster, moisture froze, seals cracked, engines harder to start. German crews needed to change filters every 100 kilometers in winter. They didn't have enough. Oberfeldwebel Klaus Richter, 12th SS Panzer. Richter's Panther advanced 40 kilometers, then the fuel filter clogged. Stopped to change filter. Used my last spare. Company supply, no filters. Division, no filters. I was told, advance until tank stops, then abandon it. That's when I knew we would lose. Richter's Panther traveled 18 more kilometers before the engine overheated. He abandoned it. December 19th. Panther's service life, 33 days. Combat engagements, 4. Cause of loss, fuel filter. The captured fuel problem. Germans captured American fuel depots, millions of gallons, but they didn't capture fuel filters. American depots didn't stock parts for German tanks. Oil filters, spark plugs. German tanks had fuel, but couldn't keep engines running. December 22nd to 26th. Collapse. 1st SS Panzer operational rates. December 22nd, 58 tanks, 58%. December 23rd, 47 tanks, 47%. December 24th, 31 tanks, 31%. December 25th, 22 tanks, 22%. December 26th, 18 tanks, 18%. American 3rd Armored, same period. December 22nd to 26th, 84 to 92% operational throughout. Americans repaired faster than Germans could break down their own tanks. Battle of the Bulge, final count. German tank losses. Total committed, 1,400. Destroyed by enemy fire, 380. Abandoned due to fuel shortage, 420. Abandoned due to mechanical failure, 505. Of the 505 mechanical failures, major failures, 180. Minor parts shortage, 325. 325 tanks, 325 million, lost because of parts worth less than $50 per tank. More German tanks lost to logistics than to American guns. The bulge broke Germany's last armored reserve. But in the final months, as Germany collapsed, fuel filters would finish what remained of the panzer forces. Germany, March-April 1945. The war was lost. Soviet forces from the east, Americans and British from the west, but German tanks still fought and still broke down. January 1945 production. Ball bearings, 38% of 1943 levels. Tank production, 22%. Fuel filters, 18%. Oil filters, 15%. Spark plugs, 12%. Small parts production collapsed faster than major systems because small parts factories were in every bombed city, couldn't be dispersed, and weren't prioritized. By March 1945, German logistics had completely broken down. Lieutenant Hermann Bix, Panther commander, final journal entries. March 15, 1945. Filter clogged, 80 kilometers since last change. Installed last spare, no replacements available. March 18th. Engine running rough, filter fully clogged. Requested emergency supply, told 2 to 3 weeks minimum. March 20th. Cannot move. Attempting to clean filter with gasoline. Drove 5 kilometers before engine quit. March 23rd. Ordered to abandon tank and join infantry. Destroyed engine with grenade. Tank otherwise undamaged. This is the 4th tank I have lost to maintenance issues. Never lost one to enemy fire. The Panther is an excellent tank, but excellence is useless if it cannot move. Bix's final Panther. Built January 1945, 68 days service, 2 T-34s and 1 Sherman destroyed. Cause of loss? Fuel filter. Bix survived the war, became an automotive engineer, spent his career designing vehicles with maintenance simplicity as primary goal. He never forgot the Panther he destroyed with his own hands because of a $3 filter. The final accounting. German tank losses, entire war. Total produced, approximately 25,000. Combat destroyed, approximately 11,000, 44%. Abandoned due to mechanical failure, approximately 6,500, 26%. Of mechanical failures, major failures, approximately 2,200. Minor parts shortage, approximately 4,300. 4,300 German tanks lost because of parts worth less than $100 per tank. At $100,000 per tank, $430 million in losses due to lack of small parts. The fuel filter didn't lose Germany the war. Many factors contributed, but it symbolizes why Germany lost. They built masterpieces that required perfection to function. War is never perfect. Fort Knox, 1947, U.S. Army post-war analysis. Colonel James H. Polk wrote a comprehensive report on German armor logistics. German tanks were mechanically superior to American designs in nearly every category: armor, guns, optics, engineering. German logistics were inferior in every category. When we designed the Sherman, we assumed fuel would be contaminated, maintenance would be delayed, parts would be scarce, operators would be undertrained. When Germans designed the Panther, they assumed fuel would be pristine, maintenance would be timely, parts would be abundant, operators would be expert. War is chaos. German assumptions required order. American assumptions accepted chaos. We built for reality. They built for theory. Theory lost. The philosophy. German approach. Build the best possible tank. Supply system will adapt. American approach. Build a tank the supply system can support, then build that supply system. Germany started with the tank and hoped logistics would follow. America started with logistics and built a tank that logistics could support. One approach leads to masterpieces that don't work. One approach leads to adequate tools that win wars. Modern parallels. Tesla Cybertruck, 2024. Sophisticated design requires specialized tools. Parts availability, limited. Service centers, sparse. Result, owners waiting weeks for simple repairs. Ford F-150, 2024. Conventional design, standard tools. Parts, ubiquitous. Service, thousands of locations. Result, repairs in days. Same lesson. Sophisticated, not better if it cannot be maintained. Post-war impact. The fuel filter lesson influenced military procurement for 80 years. Korean War. American tanks designed with maintainability first. 90% plus operational rates. Gulf War, 1991. M1 Abrams maintained 98% operational rate during 100-hour ground war. Modern era. Every U.S. military vehicle has maintainability as design requirement from day one. Logistics systems designed before weapon systems. The Soviet lesson. Soviet Union studied German failures extensively. Result, T-34, T-54, T-55 philosophy. Simple, crude, easy to maintain by conscripts with wrenches in Siberian winter. Soviet tanks weren't as sophisticated as German Panthers, but they could be maintained anywhere. That's why Soviet armor doctrine dominated for 40 years. Oberfeldwebel Hans Becker, the soldier from our opening, survived the war. In 1979, he was asked what he remembered most. His answer reveals the final lesson. Hans Becker, interview 1979. Sitting beside my Panther, a machine worth more than I would earn in my entire life, knowing it was useless because of a part that cost less than a beer. That's when I understood we would lose. Not because our soldiers weren't brave, not because our tanks weren't excellent, but because somewhere, someone decided that making perfect filters was more important than making enough filters. Perfection is the enemy of adequacy. In war, adequacy wins. Every time. I learned to appreciate simple things after that. Things that work. Things that don't require perfection to function. That Panther was the most beautiful machine I ever saw. But give me a simple tool that works over a masterpiece that doesn't. Every single time. The fuel filter that stopped the Panther wasn't dramatic. No explosions, no heroic battles, just a clogged paper element in a metal cylinder. $3 worth of parts that stopped a $2 million tank. Because wars aren't won by the most sophisticated weapons. They're won by weapons that work when everything else fails. And that requires one thing. A supply chain that never stops delivering the boring, unglamorous, $3 parts that keep machines running. Germany built masterpieces. America built supply chains. Supply chains won.